Hey, I'm Alex Frankenberg. I'm in Miss Perez's 6th period class, and I'll be demonstrating Boyle's Law.
Hey, I'm Don Kiladescu. I'm in Miss Perez's 1st period class, and I'll be presenting Gay-Lussac's Law.
Hey, I'm Felix Zuo. I'm in Miss Perez's 1st period class, and I'll be presenting Charles' Law.
In this experiment, we'll be demonstrating Boyle's Law, which states that the volume varies indirectly with the pressure. This means that as the volume increases, the pressure decreases. Here we have a balloon, which volume is 113 inches cubed. Now we're going to add this weight, which is equal to 0.2 atmospheres, which will decrease the volume of the balloon. Okay, well this is Boyle's Law. This right here, V1 times P1 is equal to V2 times P2. This is the formula for the sphere because the balloon is a sphere, and we got that to be 113 inches cubed. This is the original pressure, which is 1 atmosphere, which we're just leaving it. It's like, that's when we didn't move it at all. That's just what it was. And then this P2 is when we added the weight to it, which increased it to 1.2 atmospheres. This over here is the plugged-in proportion, and then so our theoretical yield is 94 inches cubed. And what we actually got was 96 inches cubed, so we weren't that much far off. And then I just wanted to have fun, so I drew some pictures.
Hello, I'm Dan. Today I'm going to be demonstrating Gay-Lussac's Law. This law states that as temperature increases, so does the pressure. I'm going to prove that law by driving around my dad's car until the tires heat up from the friction with the road. Hopefully that will also increase the pressure. So for starters, we're going to test the tire temperature to see what we start off with. So the temperature is, hold on a second while it stabilizes. So it seems about 23 degrees Celsius, which happens to be the room temperature, so that's about right. Alright, so now I'm going to go drive around a little bit. Right now the pressure reads 33 psi. And then we'll see what it is when we get back. Alright, so I just got back from my trip. Tire pressure did in fact increase to 35 psi if you want to go take a look. And I will be taking the temperature of the tires right now, and they read about 48, seems to stabilize, so 48 degrees Celsius. Alright, this is Gay-Lussac's Law, which states that as pressure increases, temperature also increases. This is the formula for Gay-Lussac's Law, which is pressure 1 over temperature 1 equals pressure 2 over temperature 2. In our experiment, the original pressure was 33 psi. The original temperature was 23 degrees Celsius, which is converted to 296 degrees Kelvin. The finishing pressure was 35 psi, and the finishing temperature, we are trying to figure out that. So we're going to solve for it using this formula. So it's 33 over 296 equals 35 over T2, which is the temperature. So to solve for that, you do 296 multiplied by 35, all divided by 33. So that gives you T2 equals 318 degrees Kelvin, which converts to 45 degrees Celsius as the finishing temperature. The actual finishing temperature was 48 degrees Celsius. So we were pretty close.
Alright, we're doing Boyle's Law right now. This water bottle has 500 milliliters, or it can hold 500 milliliters. The room temperature right now is 73 degrees Fahrenheit, and we're going to put it in the freezer for 10 minutes. Alright, well, we have our graduated cylinder here. It has 40 ounces right now, and we're going to stick the water bottle inside it to see the change.
Alright, this is Charles' Law, which states that as volume decreases, temperature also decreases. This is the formula for Charles' Law, which has V1 over T1 equals V2 over T2. V2 is what we are trying to find in our experiment. In our experiment, we started with a 500 milliliter bottle, which converts to 0.5 liters. The starting temperature was 73 degrees Fahrenheit, which converts to 295 degrees Kelvin. The end temperature was 10 degrees Fahrenheit, which converts to 261 degrees Kelvin, and we were trying to find the end volume. So we plugged our information into the proportion. So it was 0.5 over 295 equals V2, which is what we're trying to find, over 261. So when you solve for V2, you have 0.5 multiplied by 261 divided by 296 equals V2. So that gives you a V2 of 0.441 liters. The actual volume of the bottle was 0.46 as we measured it, which is 16 ounces.